to the first IMO problem, the International Math Olympiad ever. Now, just a special case here for n equals 0, 0 is certainly an integer. We get the fraction 15 over 7. Now, this doesn't prove anything, it just shows you it holds for the case n equals 0. 15 over 7 is a reduced fraction. Okay, 15 and 7 have no common factors. So 15 over 7 is certainly reduced here. Okay. Now, we need to do it for the more general case, folks, and so we're going to use this result right here that says the greatest common factor is equal to 1 if and only if it can be written as a linear combination where x and y are integers. This has a name, I think, called Bézout, but in any event, 22 and 25, certainly the GCD is 1 by inspection, but also notice that it admits this representation right here, where this would be 176, I think. 176, and then this term over here, this summand over here would be, what, minus 175? Well, it has to be. I hope it is. Okay, minus 175. Okay, so that motivates us to see if we can find similar values for 13n plus 15. Let's write that down. 13 n plus 15. All right, and then we need to find an x, I guess is the letter we're using here. We need to find an x, all right, plus the denominator of our expression, which is 6n plus 7. We need to find a corresponding y in order for this to all equal 1. Because if we do that, we will have a numerator and a denominator with no common factors. Whoops, we need to put a y right here. Sorry, y'all left out the y. And that all has to be equal to 1. Sorry about that, y'all. That's supposed to read 6n plus 7 quantity times y. Now, you could actually, I guess, do the division algorithm on this, but I just usually choose, usually you can do these things by inspection, and it turns out that the value of x that gets the job done right here would be -6. Now, this is fairly easy to figure out because you know you need to get the n terms to go away, okay? So notice that this -6 times 13 is minus 78, and so we would choose our y correspondingly to be 13. So let me put the 13 right there. Okay, then after that, it's not hard to verify. 7 times 13 is what, 91? Okay, and then minus 6 times 15 is minus 90. So this does indeed equals 1. Okay, so what we've shown is that 6n plus 1, we've shown that these two guys have no common factors. So we have shown that, just copy it down again. We've shown that 13n, what was the problem? I've already forgot. Okay, 13n plus 15. 13n plus 15 and over 6n plus 7 is reduced, since 13n plus 15 and 6n plus 5 have no common factors. 6n plus 7, whatever I said, is reduced. Now, perhaps it would be more circumspect if I would just write down what this result above actually means. I should write that down again, I suppose. We have shown that 13, the GCD of 13n, and I should have written this down first. The GCD of 13n plus 15, and I could be really annoying if I wanted to put that in parentheses, but I won't. Okay, hopefully the comma delineates it good enough. So 6n plus 7. the greatest common factor of those two values, which are the numerator and denominator of the above fraction, have no common factors, right? In much the same way that 25 and 22 have no common factors, 13n plus 15 and 6n plus 7 have no common factors, which means this fraction is reduced, and that's what we set out to prove. Folks, and I think a problem like this was very close to what was very close to an IMO problem way back in 1959. This is not the same problem, but it's the similar type of problem where you're trying to show an expression is a reduced fraction for all n. They may have been for all positive n, but I think it's for all integers. Maybe I'm wrong about that. But anyway, I hope you enjoyed.